All right. Woo! Yeah, get pumped. So who has heard of RX? Who has used RX? Who wants to use RX? All right. Hopefully, I'm going to change all your hands. All your hands. No, I'm going to change the no hands to hands. Okay. So here's my agenda. They're all questions. What is RX? No. So RX stands for Reactive Extensions, and this is directly from the website. ReactiveX is a combination of the best ideas from the observer pattern, the iterator pattern, and functional programming. So I'm not going to talk really about the iterator pattern. If you want to go look at the Wikipedia article, it's pretty trivial. You've all dealt with it before. Functional programming is a semester's worth of study, so I'm also not going to dive too deep into that. Ideally, some of you are familiar with the concepts of that. I am going to talk a bit about the observer pattern up front. How many people have heard of the observer pattern? That's good. I'm going to talk about it anyway. So the observer pattern, in this, I made these diagrams myself, so it's probably oversimplified, just so I can make my point. But the idea is you have a subject, object, something, right, that handles its own state. It has a list of what are called observers, which I'll talk about in a second, and it knows how to notify these observers when that thing's state has changed. And on the other side, you have observers, which are other objects that can register with that subject, or attach, sometimes it's referred to as, and they get notified. They're kind of passive, and they get notified by the subject when stuff changes. So how many of you guys have used, I know on the Android side everyone's going to raise a hand, but something like an event bus? You guys have that on the iOS side. So that's basically a good example of this, right? You subscribe to events from this bus, and you don't really know where they're coming from necessarily. All you know is, I have a bus, I'm registered, and I can accept this type of data from the bus. So why is that a good thing? Like I said, when you're an observer, when you're watching this stuff come in from the subject, you don't need to know what the subject is doing. All you need to say is, hey, I can accept this stuff at any time as long as I'm registered, right? So you separate all of the stateful things over here from things that just need to be updated by it. So it's a nice kind of clean line between state and things that watch the state. And furthermore, the subject really only has to expose externally that it produces specific types of data at any given point, really, or over its life cycle. So RX just has some different terminology that we should talk about. I'm gonna mostly be talking about observables, which is what you're mostly going to use with RX. An observable is a type of subject in that it's something that you can listen to for data from. If that makes sense. So it's something that you can subscribe to, attach to, and receive data from as it produces it. An observer. So I'm going to use the words subscriber and observer kind of interchangeably. If I was better at putting this lecture together, I would have probably chosen one, but I didn't, so it's a good exercise for you to get used to the fact that it's the same idea. But again, so observable is something you watch for data and emits data. Observer is something that waits for data and does whatever it needs to with it. In RX, you're going to be creating both. And so, all right, so we're going to talk for a second about data streams. And streams are what flow from observables to observers, right? So it's just the data that gets passed in between. It's important to think of it as a stream. You'll see later on why it's important to look at it as a stream, because RX provides you with all these awesome tools for doing things to that stream as it kind of flows through. It's an easy way to kind of picture what RX is doing along the way. So yeah, the stream is a sequence of ongoing events ordered into it. This is kind of a subtle thing that's pretty cool about RX. Kind of one of the big takeaways here. Anything can be a stream technically, right? Anything that can send you data or can tell you about itself can be a stream. And all of these things, I think at some point, if you're using RX a bunch in your app, you will probably kind of wrap those in an observable and send data out of it. And as I said before, streams flow from observables to observers. And another subtle point here is that when you're looking at the observer pattern, everything is asynchronous even when it's not. And what that means is, since all you're saying is, I'm going to subscribe and listen to events, there's no concept of blocking there, right? So the subject can be doing whatever at any time, can be doing web requests, can be waiting for button clicks, and then just send the data to the observer when it's ready. And so even if all your observable is doing is just doing a simple calculation that's just, like one method and return something, the way it forces you to design as if that's asynchronous, because you're still using the observer pattern. You're still saying, hey, observable, you're doing something and I want to listen to it when you're. So there's no concept of blocking, even for things that can really just be a single method call, something that's usually synchronous.
When you talk about a data stream, are you generally talking about like a sequence of the same event happening over and over, or can it be like lots of different events mixed into one stream? Is there a usual?
Yeah, so I can see how that's confusing. So a data stream, in the context, getting more specific with RX, it's really like a series of events of the same type. So it's basically objects of a given type coming at you over time.
But there are ways to combine those things into disparate heterogeneous data streams.
Oh, why? Why do we like it? So this is what I was saying before. So you have these chunks of code in your app already, right? You have things. You have just a module that is a web request, and when it's done, you have a callback and you pass it the response. Clicking a button is kind of similar. It's really like a web request to your body, and your finger is the response. You can think about that. That's something that someone else wrote that on a blog, and I was like, whoa, that's silly, but it kind of that helps you think of a button request as asynchronous, right? Because it's something, it's quick. You do it once, and something happens. So that's kind of what I mean by that. Or simply, you call a method and you return a value. Either way, all of these chunks of code, at the end of the day, they're going to send something a value. And I'm using value here as kind of a type. So pretend I'm talking objects of type value. So RX makes it really, really trivial to make these completely interchangeable. And so you can very easily wrap a web request in an observable, and again, it just becomes an observable that emits type value. Same with clicking a button. It just emits type value. Even just a method can be wrapped in an observable, and it will spit out the value instead. So basically, it turns everything into the observer pattern, right? And if we think back to the event bus example, an observable really you can think of as like a tiny little event bus that you only use for specific things, right? And so the reason we and tend to overuse event buses is because it decouples things serving up information from the things taking that information. So this really is a nice kind of cheap way to wrap everything in that pattern and decouple either a web request, button click, whatever, from the things that listen for that value. So here's an example. Say we're talking about tweets, because that's what everyone does when they're doing a lecture on, like an intro lecture. So say you have 3 different observables. You have an observable that goes to a web server, fetches all your tweets. That is an observable of type tweet, right? It'll go do whatever with the web, spit out tweets. Another option is, say you have a database in your app. You can go to your database and fetch all of the cached tweets that you have there. Same thing. To the client, it just looks like something that spits out tweets. Or say you hit a button and you just want to emit hashtag YOLO. That is also just an observable that spits out tweets. So to our subscriber down here, that I'm just saying, the subscriber takes in a tweet and prints a tweet. So to the subscriber, which is probably your UI or log output or something, all of these things are completely interchangeable.
That seems like that would be really handy if you wanted to, for instance, I don't know, write tests or something.
Exactly. Makes mocking very, very easy. That's a nice little side effect. So something subtle about this, though, that kind of took me a second to get used to. These are observables of type tweet, not of tweets. So there's a difference between observable of tweet and observable of collection of tweet. And so what this observable is making a promise that it is only going to pass one tweet at a time to whatever's listening to it. So and the subscriber says, I can only accept one tweet at a time. And so whatever happens in here is limited at the end to spit out one tweet at a time. So if you fetch a list, you're going to have to iterate through that and spit out one tweet at a time. We'll talk about later how you can do some cool stuff to avoid that. But so that is different from this, right? So now these two are likely going to be lists, right? You're going to, if you have cached tweets, hopefully your timeline is more than one tweet long. Web server and database are both going to have a collection of tweets. So now our subscriber can take a list of tweets, and now it's on the on the client side, the responsibility is to do the iteration and print out. And you'll notice in the last one we actually have to make a list with a single element, because that observable is promising that it's returning a list of type tweet or emitting a list of type tweet. So subtle difference, but important difference. So an observable of type is promising that it's only going to emit one instance of that type at any time. So backing up a little bit, I just showed you that you can turn these little modules of your app into observables, which I like to think of as kind of the like RX building blocks, RX Legos. And you're kind of redefining your API such that you're basically drilling Lego holes into it and letting it speak with other things that are Legos, which is nice, which is a good thing, because now your whole app, assuming you're going to RXify your whole app, which maybe don't, but the different parts of your app that you RXify are going to be able to talk to each other in some way, because it's just a simple contract of I emit this type of thing, or I accept this type of thing. So we talked about how they become building blocks, right? Everything gets wrapped up, and now it's just a unit that emits whatever. So let's talk a little bit more about the data streams, because this is potentially the more important part about RX, and when RX becomes extremely useful. So, transformers. I think these are, Ben was saying these might be the new transformers. This was like the first thing, it's like, I searched Google Images for transformers. I did not recognize these guys at all.
Maybe he transforms into a segment.
But they're from the Hasbro website, so it's real. So I put transformers there because when you're dealing with data streams, RX provides you with all of these awesome tools to manipulate that data stream as it flows from one place to another, whether that means merge it with other data streams or just, you know, filter the data in some way or just otherwise transform the data. So even if your observable isn't providing exactly what someone's observer wants, chances are there's a little component you can stick in the middle to make it. So all right, here's an example that I kind of messed up a little bit. I'm trying to figure out exactly what I messed up so I can explain.
Print number of tweets is what you meant?
No, that's probably not what I meant. Yeah, exactly. But I did that on purpose. So what's this next one? All right, no, maybe I did it right. No, okay. So this is supposed to say iterate through list and print tweets. Okay. So say we have this observable of type tweet that we built, right? So I have one that's hard-coded with YOLO. So this is perhaps a button click that emits YOLO. But my subscriber I designed to accept a list of tweets, right? Because I want to be able to handle one tweet or many tweets. So what can I do in the middle here? I can make a transformer that maps tweets into lists of tweets. So there's a separate component now that I can simply chain to the end of my observable, which actually generates a new observable, that is going to take in a tweet and return a list of tweets. So in this case, I'm going to design it to just, you know, make a new list and add one item to it and spit out that list. And so now I have this component which can remain the same. I have this new component which I can just stick in when I need to, and I don't have to change my subscriber. My subscriber can still take, you know, a list of tweets. And an even better option is you can make it generic, right? So you can make this transformer take in any type and return a list of whatever that type was. And as soon as I tack it onto this observable, it becomes whatever type I passed it from the observable. But obviously that makes it reusable, right? Like there's a good chance maybe I'm going to need to convert a single item to a list of items anywhere. And so here's another example, right? Say I have tweets, but I want to display the length of the tweet, and that's where that came from. So I'm going to make a transformer from a tweet to an integer, and it's just literally going to say it's going to return the length of that tweet. And now, again, this could be whatever that gets a tweet. This could be whatever that displays the length of the tweet. And now I have this component in the middle to help me transform it. And this is what I was saying earlier. As soon as you pair a transformer or a chain of transformers to an observable, it looks to the client as if that's just one big observable. Again, the client has no idea what's happening before it gets the data. So really, this is just the equivalent of having observable of type integer. And so if I wanted to sub this whole thing out with something that I just hard-coded the number 5 in, I could do that because, again, it's to the client, it just looks like observable of type integer. Does that make sense? Any questions so far?
I had a question about you had the 3 different types of tweets that were coming in. What if you did care where it came from, but you still wanted to observe all new tweets? Like, is there a good way? Maybe it goes back to having a better data structure.
I want to get.
Like maybe maybe the tweets print in different colors and they get printed out based on the source.
Based on the source.
Yeah. Like, is the solution to make a data structure around the tweet that that's actually what's getting transmitted, or is there a different way to also say who the sender
So
is?
there are ways with RX, and I don't know, I'm wondering if the stuff I'm going to cover later on will kind of answer that, but at the end of the day, you have 3 observables that emit tweets, right? You can put something, you can build some kind of transformer in the middle that says, hey, listen to these 3 things, and based on which one, assign it some kind of value, right? Like, you know, an enum that says web, database, or button. And then, from there, it will emit a type marked tweet, right? You make a new type that's like marked tweet.
Sure.
And again, to the observer, that whole thing looks like observable of type marked tweet. So you can totally do that. I'm not going to get into the specifics of how you merge that stuff.
Yeah.
But yeah, again, you can totally, if you want to add something in the middle, this makes that very easy to add something.
If I can sort of add to that, though, like you generally wouldn't want to do it based on like what observable is coming from. More often you do it based on something about the source that you would describe in your data model.
Yeah.
Because maybe you add maybe have another observable that's emitting like the same source in each way of your two different screens, and you still want them to be tagged the same way or something.
Anything else before I keep moving?
So the transformer knows about the observer, the source knows about.
Yeah, it's basically actually what's really happening is the observable is an object, and then this is like object.add transformer, and then it returns a new object, which is that. So it looks kind of functional when you're looking at it in code, but really what it's doing is just kind of building this object that at the end of the day, that's all the subscriber observer cares about.
Just grab that last one.
Just stressing you out. So other huge advantages, and iOS people correct me if like we diverge here. But one of the big things on the Android side is scheduler thread management. So say you have a chain of transformers, and you can even string observables together, right? When one observable finishes, start this next one, transform that data, then start another observable. At any point in that chain, which, as I mentioned, is not really a chain, but we're going to think about it that way, you can switch threads just by adding a single link to that chain. So you can have the first part of your chain run on a separate thread, and then all you have to say is, at this point, I want to observe on the main thread. And Android, I assume there's some concept of or I guess UI thread is a better, more universal term. So you get to a certain point, you say, I want everything that executes after here to happen on the UI thread. And then even later on, you can say, okay, everything after here back on a different thread again. And so for Android especially, that's really nice to be able to just know for certain at the end of any observable to just plop in, run this on the main thread, especially if you're having UI observe it, because you have to update your UI from the main thread. So to be able to just add one line to this kind of modular chain that just says, hey, this has to be here is really, really nice. Another good example of like switching back and forth is say you want to update the UI, but like you want to just give it some like a progress update. You can have your observable running, and then have the thing that updates the UI alone run on the UI thread. So you don't have to. I guess that explains itself. The other thing is, so I put cross-platform. So obviously we can't just copy and paste each other's code or like look at a single repo yet, but I know Vincent and I actually, this worked out in our favor big time in PNG. We can share patterns. We can share, because at the end of the idea, we're working with the same models most of the time, and again, we wrap up our platform-specific implementation in observables, and then we can talk to each other as if we're writing the same app because we're just dealing with these observables. So that's a huge advantage that I didn't even think of until we started talking about it. That's a big one. When do you use it? All right, so I came up with a few examples. There are like infinite examples of this being useful, but all the time. So asterisk, because you're never supposed to say that. There's the old saying, what is it, if you have a hammer, everything looks like a nail type thing. It's like, and I remember when we all learned about the event bus, like all of our apps suddenly like routed every possible thing through the event bus. So, you know, use it when, learn how to use it and then use it when it's appropriate. But I will say RX, more than any other library I've dealt with, doesn't end up kind of restricting your behavior and architecture. And so it's generally pretty safe to, you know, to refactor, to use it, to add it, even at points in your app. It's pretty lightweight as far as, you know, the internet is telling the truth to me. I didn't actually like Measure. But, so, you know, don't go ahead and put it everywhere just yet, but it's generally a pretty safe thing to add. The other thing to consider is you have teammates who might not be good at it yet, and it's very strange to read if you're not used to kind of how things are flowing and the specific keywords when you're using the transformers. So just keep that in mind. You know, if you're going to throw it in, make sure everyone's on the same page first.
RX also, more than most libraries, has at least for a lot of people that I've talked to, has a really distinct cliff moment. Like
Yes.
there's the before you get it, and then there's the after you get it. And like once you get it, it's like, oh right. But that takes a little getting to, so keep pushing at it.
And there's a lot of stuff that just happens because of RX. So
Yeah.
if you're jumping on a code base that has it, and you're looking for that method that updates that label and you can't find it, it's because RX just automatically binds it. And so there's a lot of like, it's nice to tell your team members that there's RX in certain parts of the app because there could be some magic happening if you're looking for it.
Yeah, so all the time. So all right, so here's some scenarios that we have all dealt with and that RX makes pretty trivial. So imagine a world where you make a web call. Using data from the response you get, you make another web call. And say, you know, this is trivial at the end. Now you want to cache those results, or you want to display some combination of the results on your screen. And I see Dean is kind of giggling. Do you have experience with this?
I'm doing this right now, so
I know you are. That's why I put it in. So like I don't know if you're doing it for like Spotify stuff, right? Where some of the data is on Spotify, some of it's on Last.fm. Is that something you guys dealt with earlier?
No, I'm just making like multiple calls to the back end, like within each other, and or dealing with each other.
Sure. Great. So with RX, you make an observable for each web call. Like web call 1, say, returns object person, right? Or that's what you're expecting to get at the end of this web call. So you have an observable that emits person. Web call 2 takes the person's name and gets their photo, right? Gets their image somewhere. So that's going to return an image at the end. So that's observable of type image. Now what you can do is, I won't get platform specific Cody, but basically you can just chain them together. You say, this observable emits type person. I have a map. It's really going to be a flat map. You'll learn all about that when you dive in. But that takes in a person and returns an observable of type image. And then at the end, you just subscribe to this whole big observable of type image. All that stuff gets kind of wrapped in its own thing, and then at the end, all you have to worry about is the last result you need. So that's one example. Here's this one's an even cooler example, I think. You make a web call. You make a parallel web call. And then based on the results of both of those things, you make some kind of decision or you update the UI that shows both of these things at once. You guys are now smiling. Is this something you've dealt with? Or are you just smiling?
That's entirely the ringer.
Okay. Now you can do all this stuff without RX. Obviously, like this stuff has needed to happen for a long time, but you know that means you kind of have to keep track of the status of each web request and like what do you do if one fails, if the other fails. RX, there's something called just zip, and it takes two observables as an argument. Observable of type A and observable of type B, let's say, and you just get, from that, you get an observable of type A and B. And so this, it will only call your observer when it has both. And there are some subtleties there that you'll learn from the documentation, but the idea is give me any number of observables and I will give you an observable that returns and will have a callback that passes back one of each type that that list of observables define. If that makes sense.
So if one of them fails, does it just keep on going?
Great
No,
question.
that is a great question, which I will get to that. Default behavior is if one of them fails, your observer will just get failure notice, and that's it. But I'll talk specifically because on error, which I'm talking about, is a big part of this. Glenn's example. You say you have a list. This is a simpler example. You have a list of full name objects, but you only wanted last names. And so rather than, it's pretty trivial to just iterate through and create a new object and build a new list, add all those. For this, you have an observable of type full name. You have a map in the middle. You have a transformer from full name to string. You have a subscriber of type string. And that's, again, all of those pieces are reusable as long as you build them that way. And it's just that much quicker than writing that for them. I'll give you a second. So my point here is that this is not that with RX would not be that much more complex than the previous examples. As long as you build each unit, each observable, right? So one for clicks, and then to that click thing you add a filter that says only pass through every third one, and then after that you go to the Febreze backend and you check the status of it, and when that comes back, you observe the last time the last event went through, and if that was more than 5 seconds ago, allow this event to go through. Oh, and then email. So if it's Tuesday, and so you have an observable. Email your mom. You have filter 5 seconds. You have observable that fetches Febreze status, and you just glue them together, and it just becomes this one beautiful thing that emails your mom.
So this would be a good example of the A plus B thing, right? Where, okay, you've got an observer that's the third time, that's like a third time click, and then you've got an observer that's your boost mode, and you combine those and then say, okay,
Yep.
these two things.
Yep. Or you could say, so the observer on click and the observer on third time click, that's just observable of click plus a filter that filters out click events. And so now you've got wrapped up, you have observable, it's still of type click, but it did some magic in the middle to filter out. And then, so there's that, and then there's the status thing. You combine those two. This is the best part too, is say, rather than combining those two, say, instead of prefetching the status, you want to fetch the status after the click comes through. There's just a tiny bit of rearranging you need to do, literally like a line difference to make that the new chain of events. So the point is that doing something crazy like this is really not that much more complex than the previous examples. Dave just arrived, so I'm going to give him a sec to read my app idea.
I don't like it. You're gonna have a first time really funny. And that neighborhood thing, you get a lot.
Whatever. So here's a very practical example that I've implemented like twice now. So say you want to update your list of tweets, right? First, when you open the app, you want to see tweets right away. If you have them cached, you might as well see them right away. So what this will do is, this observable goes to the database, emits those tweets, and then it starts this other observable that goes to the web and gets tweets. And to this guy, again, this guy is just looking for tweets. He does not care what happens above. This fella is just going to get a stream of tweets from the cache right away, and then a stream of tweets from the web. It doesn't know the difference, like you're saying. It doesn't know the difference. All it knows is that this thing is passing it tweets. And so I think, yeah, so this, again, just equals that. And so if you need to change this behavior, say you want to check the cache, and then check another cache, check your shared preferences on Android because you decided to store them in a weird way, and then go to the server, or you want to parallelize the two, your UI code does not give a shit what you do. These are completely interchangeable, and it's a really nice way to separate things. Yep.
So the merge doesn't wait for the other one to...
No, this diagram is kind of ambiguous in that way, but you could do it either way. You could do it. You could run them since fetching a database might take a while too, or making a query might take a little while. You could just kick them both off, and again, when you merge them, it's just going to get the list.
You've got something there. That merge thing is something that's listening for observable tweets and then emitting more observable tweets, or like
The merge thing. So
It's like combining the streams.
it's combining the two.
Yeah.
And so this is what turns this into that, right? The merge says, I've got these two observables. I want to turn them into one observable type tweet. So take these two sources, funnel them together, and then now it's only one source.
And then it's trivial if you want to add one more thing after that merge that would, for instance, only pass through tweets that have not already been seen to avoid duplicates between the cache
You
and...
just stick that right here. Or, again, so it's your building block. So you can stick that here. You can stick it only on the web server side. You can stick it only on the cache side. But yeah, the idea is you have multiple observers. You can combine them. It just appears to the client as one observable.
I think one thing to clarify on that is like the observable is just a sequence of tweets, right? It says tweet, 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 tweet. And so you have two things that are just tweeting a bunch, and the merge will just say take whatever comes first and pass it through. And so it says like it kind of just throws in whatever order it comes in.
Yeah, I'm going to redo this diagram because I also put the and then here because my idea was get the cache first and then get the web server. So then you don't really have to deal with the whole like interleaving potentially, because this is a stream of tweets. It is not I said list. It's not a list. It's a stream of tweets, not a stream of list of tweets. So yeah.
It's also worth pointing out, like merge here can be up to things. Like there's an operator that is merge.
Let's ignore this.
But there's other ways you can do that. So
This was supposed to be more abstract, just kind of like it's kind of more confusing than it needs to be. Okay, so how that's just a sampling of stuff you can do with it. There's so much other cool stuff, and if I had spent a little more time digging through my own code, I probably should have pulled out a few more. I might just keep adding to the slides in a way that hopefully you can pick up on your own. But getting to the how stage, so try to keep this completely platform agnostic. So there are no code examples. I think we're planning on doing a follow-up lecture. At least Android is. I know DZ is going to probably do some more specific examples. So part 2, iOS, you guys should do the same or else just be embarrassed. never better. But no, but so no code examples. Again, keeping it pretty high level here. But I do want to talk about the 3 key methods that your observer needs to implement. So these are 3 methods that any observable can call at any time, right? On next, on completed, and on error. Pretty straightforward. So you have an observer, you've subscribed to something that emits tweets, right? For every tweet that comes through, your observer, which has implemented the onNext method, is going to get a call on next, and it's going to get passed a tweet. If the observable is out of tweets, like if you have a list of a given size, after it has sent you every tweet via onNext, it's going to send you an onCompleted event, which is really nice because then you know when to stop. Then you can, maybe transition to the next part of your UI animation thing. I don't know, but that is a really nice thing. Important to note that you can have observables that are just kind of always on and will never send you an onCompleted event. So that's like an event bus is basically that, right? The event bus doesn't say, hey, I'm done being a bus, so stop listening to me. So you can have either depending on the situation.
Is that super expensive? Like on the page, should you just stop listening and get rid of your server?
A lot of internal stuff will do that.
Yeah.
Things that are doing internal.
Oncompleted should know how to kind of clean up after itself. On error is pretty self-explanatory. If at any point in your code, in your observable, an error gets thrown, an exception gets thrown in Java, I don't know what the hell you guys have, but if there's an error, it passes you that error, and by default, and I'll talk about this more when I dive into that, but by default, that observable will stop. So if you say you're going through your 5th out of 10 tweets, and the name is invalid and you get a null pointer exception, you're not going to get those last 5 tweets by default. On error will just stop. There are ways to tell it to keep going, but quickly we're going to talk about marble diagrams because these are going to be how you learn the rest of the stuff that I'm not teaching you. If you go to the RX documentation, this is what you're going to see associated with every type of transformer. This is what you will see. Pretty straightforward. So line going that way is representing time. Each bubble represents an event or basically an onNext, right? So something got passed to onNext each time this happens. No, it's not. If there's nothing in the bubble, like they put bubbles, they're generic. Sometimes in the documentation they'll put characters and integers to kind of give you more specific examples. But if it looks like this, that just means whatever your thing was, it happened at this time. An X represents an on-error event, and the line represents an on-completed event. So to make that a little easier, I took our simple hard-coded YOLO observable from before. So when you just press the button, it passes the string through. And so this is what, if we were looking at the documentation for this transformer, right, mapping a tweet to an integer, this is what it would look like in the documentation. This is your source observable. This is the transformer, and this is what your observer is going to see at the end. And so time-wise, it just goes straight down. So the associated event will just be directly below it unless there is some kind of delay associated, which you can also do here. So in this case, you can see the input is 5 characters long. So our observer is going to just get an event with the number 5. All right, so let's look at some. So someone made this awesome website, and I think RX is probably a part of it. But RX Marbles basically takes a bunch of the diagrams they have, the static diagrams, and made an interactive version. So you can move the events around and see how the output would be different. So we're going to look at a couple, And this will give you a feel too, just for how, like, what kind of transformers there are. I'm nailing time. So there's a last transformer, right? So you have an observable that emits numbers, and then you tack on the last transformer, and now your observable is only, like, you know, as a developer, that your observable is only going to emit one item. It's going to keep track of the latest one, and as soon as an uncompleted event comes through, it's going to call on next. It's going to pass the latest number, and then it's also going to pass on completed. So when you see them on top of each other, like this, that means it goes on next, on completed, with no delay in between it. Is my thinking. So if I drag 3, cross it over, since 3 was the last thing to come through that observable, through this filter, that's the last thing that's the only thing we're going to get on the other side. And so again, once you tack this on, your observable just becomes this. It just becomes observable of one integer. Cool. All right,
What
so
are the tick marks? Is that when the call is completed?
this one, this little guy?
Yeah.
So that's the uncompleted event.
So if the 3 came, 3 could not come after it.
It's impossible, so it'll just move it out. Yeah.
Okay.
Because the observer has been finished before the last one. Like if that was in a stream, then you just have to.
All right. Here's another cool one. That's very useful. Distinct. So this will only emit numbers that you have never seen before, that have not already been emitted. So again, to the client, it just looks like observable of integers, right? Like it doesn't know what's going on. Once you tack this on, it becomes one observable. The client has no idea. But now, and unfortunately, it doesn't. I wish it would let me add some, because this one's kind of pointless to move around. But you can see that a second 2 comes in. We've already seen it, so it never comes through the bottom. The second 1 comes in, same thing.
So for combining the tweets, for instance, you could use this to merge the cache.
So the color here means nothing.
Color, I don't think so, not really.
No, it means
It did until 3. I don't know why 3 is blue. 3
it doesn't
seems
mean
to be
which
red.
one you're actually getting. Like if you put the one, if you move
Oh,
the
yeah,
blue one
if
all the way to
you
the beginning, you get the blue one.
Use the order.
Move the blue one all the way to the beginning.
Yeah.
Then the one on the bottom will change. Yeah,
Yep.
that's why.
All right, cool. Just to differentiate.
Yeah.
The red ones are the first instance, the blue ones are the second instance.
Unless you.
Except for 3.
Yeah.
And also, so just look at this one really quick. So this one's cool. This one is it's the same thing, except it only looks at the last one. So if the last one was a 2, we don't need to output it. But now the last one is different, and so we go back to our normal, regularly scheduled programming. That's nice because that's just a nice filter if you don't want to display the same data twice. You don't need to update your UI or something because it's the same thing coming through. This just makes it so you don't even have to worry about that at all.
That was really nice. That was kind of right above the same.
We use that.
We use some variation of that. Merge. This is just simply. So now we have 2
Combination.
Yes, totally, and that's a great point. And after talking to the iOS team, it's interesting. So they tend to use it a lot more for data binding, UI binding type stuff, which I honestly haven't really done yet. But
Well, because we do a lot of stuff through like Wider Knife.
yeah, right. We have other ways of handling some of that stuff, but that's a totally good point. I didn't really bring that up, but like I did say at one point, any model can be thought of as an observable, right? And so, yeah, if you just want your UI to be linked to this model's state, that's a great thing to do. Is just have the UI just listen to that model. That's a good example. And the other great like practice is just like take a list of things and turn it into a list of different type things. Like that's how you get used to the filtering and map and stuff. or you can do another easy one is you take a list of things and turn it into an observable that emits one at a time, and it'll just machine gun that whole list out and give you an uncompleted event at the end. So if you have an observer that is only accepting one thing, it's the opposite of what I showed earlier. You have a list and you have an observable that only shows one. You can easily just machine gun those things out.
I will say to Dave, your question, it doesn't work well if you mix bindings with like the more what's the other non-reactive.
Like fetching data type things.
No, you mix reactive with just what was the normal way of programming.
Procedural.
Yeah, sure. Like if you're changing a label and the label's also observing a model, like it gets really confusing if you're trying to say like, hey, like when I press this button, change the text of this model, and it also is observing some of the models. Like, don't do that.
Yeah.
One more. When has or like might this bite you in the butt?
The biggest ones I've had are just errors being like it does kind of catch stuff for you and silently deal with them. That's been one big one for me. Another thing is it can be for certain things. It does get kind of high overhead. Like I actually did a test one day where I did something like loop through a list, get some value from each item, create a new list of just those values, and I did it the RX way, and I did it just iteratively, like a for loop. And the more like transformers you add, it is going to like generate new. It's going to allocate stuff and create new objects where otherwise you might not have needed
a new stack frame.
Yeah. Like I had one in Runkeeper actually where they let me play with it like crazy, which was awesome. I had one and it was like, get this model from the database, get this model from the database, check the web. It was just a long string, and I had a lot of my database calls and queries isolated in these observables, right? And again, easy to chain them all together, but really what I needed was just an optimized query. I just needed one query that would have done it for me, and so it's easy to start chaining all this shit together, and it feels really good and it looks kind of cool. But you should definitely make sure you're not choking the UI, because there is some overhead involved in making it that easy for you.
Cool.
If you guys want to add anything else, those are the big ones.
Sometimes harder to read also.
Yeah.
And like understand that like, oh, you're doing like these 5 different transforms on this thing.
Yeah. It does. It takes a lot of getting used to, and especially like Java, or on Android, we're restricted to Java 7, I think, right?
Yeah.
Where we don't get to use the pretty lambdas, and so it's kind of these chunky parts of the chain. I mean, really, most of the chunk is just like brackets and like new action 1 object, like shit like that. But you get used to it.
Okay.
You mentioned it too, it seems potentially hard to debug.
Yes.
Yes, the
I actually had that on a
debugging
slide.
you can test it.
I've found in Xcode at least if you're trying to print in the console anything within an RX observer subscription callback method, Xcode just crashes.
That's a weird one.
So
That's strange.
So you have to do a print log there. And it just crashes.
That's a specific one.
It is very specific, but it's very annoying.
Yeah, I would say on the Java side, the stack traces you get, where it used to be like null pointer here, is you get these really long stack traces of
digging
like
through their code.
Yeah, and so it can be hard to find exactly what you're looking for. Sometimes
you have issues where you crash in your subscriber, but you don't know where in the observer you were emitting that, and so it's hard to trace through.
Yeah.
So is there any like tooling around that? Around like let me set up like emit this list of events in this order and like play this back, and I'm gonna sit here and poke through it every time you play it back. Like, is there any tool around?
I bet you could build it. I mean, just by nature, you could probably build something that plugged in and did
There's some test stuff that's built in. I don't know if there's any hard debugger stuff.
Okay.
That's the other cool thing. Like I just thought of another awesome time I had with RX. Like you can have observables that stick around. Like a lot of the time, if you're making a web request, you generate an observable for that web request, and then when it's done, it's done. You know, you're done with it. But you do have some that can stick around longer, and you can have stuff like every time you subscribe to it, it'll play back everything that it ever had sent out before. So there's shit like that too. Yeah, debugging can be kind of hassle. We also mentioned testing. I think so. The testing, it does change how you test things, but I think they did a good job, and I think it's basically they have a test subscriber that you can pass to any observable, and at the end of your test, it basically just logged everything that happened, and you just say, instead of like assert that this is true right now, you walk through the events and you say assert that this one came before this one, this one, this one. Cool. The caveat there though, if you're doing anything with the threads, like the nice thread stuff they provide you when you're hopping between threads, you have to make sure in your test environment that those observables are on a test thread, a test specific thread, which basically runs everything immediately. We're talking about unit tests here, right? So since you're dealing with things that are inherently asynchronous, you have to say execute all of this immediately, all at once. You know, don't change threads basically, and that does get a little. That you have to keep that in mind when you're designing a little bit, because you have to be able to say, you have to basically inject the thread that you want to use.
Okay.
So runtime you have the use new thread, use main thread. Test time you're always using the immediate thread.
Is all Android specific?
No, completely.
Oh, that's cool. If you go on the site,
ReactiveX is across.
and if you go on the ReactiveX site, it has all the methods, and then it says which frameworks have implemented it.
Yeah.
Well, actually, all the RX Swift documentation is just like awful on that side, right?
Oh, that's not accurate.
Really?
Yeah, they always say like TBD, but they're all.
Oh, okay. Well, then disregard that. I thought that was still valid.
I think that's just like they didn't write the docs.
The other cool thing they did, so the regular RX documentation site, they have marble diagrams like this, but they're static. When you pull the library in on Android, it actually gives you the marble diagram in the Java doc. So if you hit like Control J or whatever it is on that method, it'll show you it'll show you the marbles right there in Android Studio, which is badass.
Yeah, it's really helpful when you're running your English thing you want to ask this while you're coding.
No, as an image.
No, as an image. Oh.
Yeah.
That'd be pretty good.
So again, I tried to keep it as kind of high level as possible. Looking at the code, especially if you're on the Java side, it does take some getting used to. But once you do, and if you get around to playing with it, let me know what I fucked up in my lecture. I actually did a lot of research and learned a ton doing this, so I feel pretty good about it. But yeah, please tell me when you go and you're like, oh, that's what he meant. Let me know so I can make this better. Because this is something I really love, and I'm stoked about and stoked to tell people about. So I want to make this the best thing.